So we are looking at ester formation. I have written down a couple of examples here. An ester is formed when we take an alcohol and a carboxylic acid. We add them together and then we add a dehydrating agent like sulfuric acid. Water will be removed. So the name ends in OH, and we have to then also make sure that the stem of the alcohol, very important, the stem of the alcohol will end in YL. So the alcohol ends in YL. Let's have a look at this example. Propanol, we know it's 3 carbons. We're not going to worry about the position of the hydroxyl group at the moment. And just remember to add all of your hydrogens, doesn't matter how tedious it might feel. Plus propanoic acid, 3 carbons. And for the sake of convenience, I'm going to indicate my functional group closest to the alcohol. So I already have 4 bonds around this carbon, just be sure of that. And then I add my remaining hydrogens. And now what will happen is that the dehydrating agent that we add, sulfuric acid, is going to remove a hydrogen from the alcohol and a hydroxide group from the carboxylic acid. And what will form is the following. We will have the 3 carbons of the propanol, the oxygen on the alcohol, now forming a bond with the carbon of the propanoic acid. We still have our double bonded oxygen there and our remaining carbons, and then we simply add our hydrogens. Now when it comes to the naming of this molecule, important that you remember that where we took the hydrogen or from the alcohol will now become YL at the end. So this will be propyl, and then this part will be propanoate. So the name of my ester here is propyl propanoate. If I look at another example, butanol and ethanoic acid. Butanol will have 4 carbons in its stem, and remember, because it's an alcohol, there will be a side chain of OH. Notice also that the OH, I draw a line between the O and the H to indicate the bond there. And then ethanoic acid, eth meaning 2 carbons. I already have 4 bonds around my carbon there, and now I just add in the remaining hydrogens. And what will happen is that the hydrogen from butanol and the hydroxide from ethanoic acid will combine, water is removed, and my product that will form will look like this. 4 carbons from the butanol, the oxygen from the butanol, the carbon from the ethanoic acid with the double bond, and then I simply add in all of my hydrogens. And when we come up with a name for this ester, the alcohol part will end in YL, which means that this is going to be butyl ethanoate. Butyl ethanoate. Let's look at another example, methanol and butanoic acid. So when I have methanol and butanoic acid, we know methanol simply has the 1 carbon, so we'll have the COH and remaining hydrogens, plus butanoic acid, but meaning 4 carbons in my stem, my double bonded oxygen and OH, and then I add my remaining hydrogens. Once again, I'm just going to indicate where the hydrogen is removed, it's over here, and the hydroxide. And now what will form will be the 1 carbon, this oxygen over here, bonded to the carbon from the butanoic acid with the double bonded oxygen, and my remaining 3 carbons from butanoic acid, making a total of 4 on this side. Just make sure then that you indicate all of your hydrogens correctly. And the name of this molecule is going to be methyl butanoate. Methyl butanoate. Now sometimes they will try and confuse you, and instead of writing down the alcohol first, they will write down the name of the carboxylic acid first and then the alcohol. So I still apply the same method. Propanoic acid, we know it's 3 carbons. Now just for this specific molecule, I'm going to add my double bond OOH on this side. I add all of my hydrogens, remember 3 carbons in my main chain. And now I add my ethanol, 2 carbons, and I know I have my OH group on one of them. And I make sure that I have sufficient amount of hydrogens. So what will happen here is that the hydrogen from the ethanol and the hydroxide from the propanoic acid will combine and water will be removed. And so the molecule that will form, and remember I'm just drawing it the other way around, it's still the same molecule, is going to have 3 carbons, a double bonded oxygen, then there will be an oxygen from ethanol, the 2 carbons from ethanol, and then I just need to add in my hydrogens. Now be careful when you name this molecule so that you don't make a mistake. Remember where the alcohol was, that becomes my YL. So this is going to be ethyl propanoate. Very important that you notice that the ethyl, you know that we sometimes use the suffix YL. It is used for side chains. So it is as if the alcohol is now a side chain on this ester. And that's why it ends with YL.